Hello, welcome back once again. Today we have a very interesting indefinite integral to evaluate. We have the integral of 1 over x cubed plus 1 dx. Okay, so let's get started. Today I'll be showing you guys another amazing trick. Okay, so let's call this integral I. So now we have that I is equal to the integral. So the numerator, which is 1, we can write it as x squared plus 1 then minus x squared, then divided by, here we have x cubed plus 1 dx. So from here we can split the denominator, right? So to split the denominator from here, we're going to have the integral of x squared all over 1 plus x cubed dx, right? Then we have plus the integral of 1 minus x squared all over 1 plus x cubed dx. Okay, so from here now we can call this part, we can call it A, and we can call this one here B, right? So let us evaluate A. So A is equal to the integral of x squared divided by 1 plus x cubed dx, right? So this will be equal to, if you put 1 over 3 here, then we're going to have here 3x squared, then divided by 1 plus x cubed, then dx. Okay, so there is one theory we're going to take note of here. So this is one of the fundamental theories of calculus, integral calculus. So when we have, let's use another color so that you will understand what I'm talking about. Okay, so when we have the integral of the derivative of a function, right, over the function itself dx, so this is simply the natural log of the function f of x plus c, right? So if you take a very good look at this integral, you will find out that the derivative of the bottom will give us this numerator. You get the idea, right? The derivative of 1 plus x cubed will give us 3x squared. Okay, so we're going to apply this theory here, and guess what? We're going to solve this. So this will be equal to 1 over 3 times the natural log of 1 plus x cubed. So you get the idea? I think we're done with A, right? So let's go to B. So our B is equal to the integral of 1 minus x squared divided by 1 plus x cubed dx. So this will be equal to the integral. So up there we have 1 squared minus x squared divided by, down here we have 1 cubed plus x cubed, then dx. So notice that the up here, the numerator is the difference of two squares, and the denominator here is the sum of two cubes. So let us call upon the following formulas. So we have that a squared minus b squared, which is the difference of two squares formula, is equal to a plus b multiplied by a minus b, right? So, and we have for sum of two cubes, a cubed plus b cubed is equal to a plus b multiplied by a squared minus ab plus b squared, right? So use these ideas. So our b will be equal to the integral. So up here we have 1 plus x multiplied by 1 minus x, right? So divided by, so down here we have 1 plus x, right? So into brackets, so that is same as x squared minus x plus 1, right? So we have our dx. So this is exactly what we have from here. So if you look carefully, you will see that we have some nice cancellations, right? So this and this. So leaving us with the integral of 1 minus x all over, is that 1 minus x? I think I've made a mistake, right? Okay, no, there's no problem. Okay, so we have 1 minus x all over x squared minus x plus 1, then we have our dx. Okay, so let us go ahead and factor out. So what are we going to factor out? Okay, so let us not factor out anything yet. So let us write this numerator. We need to manipulate it nicely. So this b will be equal to the integral. So this numerator right over here, we can write that as, that should be negative 2x over 2. You get the idea, right? So plus, is that plus? Yes. So plus, now 1 is same as 1 over 2 plus 1 over 2. Then this will be divided by x squared minus x plus 1. So you may not get this idea properly, but you will see the magic, okay? So if you check properly, you will see that negative 2 divided by 2 will give us negative x. Then plus 1 over 2 plus 1 over 2 is 1. So we still have negative x plus 1. So nothing's changed, right? So this will be b is equal to the integral, split the denominator, we get negative 2x minus, oh sorry, plus 1, right? So whole divided by 2. That is for this part here, making a common denominator, right? Then divided by x squared minus x plus 1 dx. So for this part here, we have plus integral of 1 over 2 divided by x squared minus x plus 1. Then we have our dx. Okay, so what do we have from here? So we can write this, let's call this c, right? And let's call this one here b, I mean d, right? So let's call that one d. So for our c here, our c is equal to, write out the 1 over 2, right? So if you write out the 1 over 2, I think we need to factor out negative 1, right? So this should be negative 1 over 2, then this will become the integral of 2x minus 1, then divided by x squared minus x plus 1, then we have our dx. So this will be equal to, remember from here again, the derivative of the denominator will give us the numerator. So this is simply negative 1/2 times the natural log of x squared minus x plus 1, right? So this is what we have from here. So how can we integrate d? So let's put d down here. So our d is equal to, let's put the 1 over 2 out, then we have the integral of 1 over x squared minus x plus 1, then we have our dx. So this denominator here, we can write it as a square of a quantity plus a constant. So you know what I mean? To complete the square. So here we have that x squared minus x plus 1 is equal to x squared minus x plus 1 over 4, then plus 3 over 4, right? So this one here is a perfect square, which is equal to x minus 1 over 2 whole squared, and here we have plus 3 all over 4. Hope you get the idea. I know your answer is yes, right? Okay, let us proceed. So our d is written as 1 over 2 times the integral of 1 all over, so we have x minus 1 over 2 whole squared, right? Then plus, so here we have, we can write 3 over 4 as the square root of 3 over 4, then whole squared. Then we have our dx. The reason, take a look at this. The integral of 1 over x squared plus a squared dx is just equal to 1 over a times the arctangent of x over a. So this is one of the properties of indefinite integral, right? So if you use that idea, we will say that we can do this, right? But we need to make a substitution here. So we can let x minus 1 over 2 equals, let's say, y, right? So differentiate both sides, so this implies that dx is also equal to dy. So our d will be equal to 1 over 2 times the integral of 1 over, so this one here is y squared plus, now we know square root of 3 is irrational, so we keep it like that, square root of 3 whole squared, right? Is that, oh sorry, so we have square root of 3 over 2, right, whole squared. Hope that is what we have. Yes, okay, so we have dy, so this will be equal to 1 over 2 multiplied by square root of 3, right? Yes, so square root of 3 over 2 right over here, right? So this is 1 all over, then times the arctangent, the inverse arctangent of, so here we're going to have y divided by square root of 3 over 2, right? Okay, so we know that these two, we cancel this 2 here, so our d will be equal to 1 over root of 3 times the arctangent, inverse arctangent. I mean the, oh god, I mean the inverse tangent, right? So what is wrong with me? Okay, so y divided by square root of 3 over 2 is same as 2y over the square root of 3. When you make your substitution again, recalling this, so we get 1 over the square root of 3 times the inverse tangent of, this will be 2x minus 1 over square root of 3. How did I get 2x minus 1? We know 2y is equal to 2 into brackets x minus 1 over 2, so open the bracket to get 2x minus 1. Hope you get the idea. Okay, so we need to combine everything. So to combine everything, we're going to have our I is equal to a plus b plus c plus d. So this is equal to, our a is equal to 1 over 3. Let's go back and check it out, right? So what is our a? So our a is 1 over 3 natural log of 1 plus x cubed, right? So we have 1 over 3 natural log of 1 plus x cubed, right? So our b, what is b? What is b? Can someone help me out? So our b, sum of c and d, right? Yes. So our c is negative 1 over 2 natural log of x squared minus x plus 1, right? So negative 1 over 2 natural log of x squared minus x plus 1, and our d, I mean, right? So our d is 1 over square root of 3, the arctangent, right? So plus 1 over square root of 3, the inverse tangent of 2x minus 1 over the square root of 3. Now we have to put our constant of integration. So here we can say that the integral of 1 over x cubed plus 1 dx is equal to 1 over 3 times the natural log of x cubed plus 1 minus 1 over 2, right, times the natural log of x squared minus x plus 1, then plus 1 over square root of 3, the inverse tangent of 2x minus 1 over the square root of 3, so plus c. And this is the correct answer. Please, if you really enjoy my video, kindly support this channel by subscribing. Please subscribe to this channel. Also like, comment and share, and please do not forget to share with your colleagues.